Welcome back everyone. Today we're going to take a look at how the root and emulator detection are actually working and how to bypass those. In the previous videos we actually already talked about those topics, but today we're going to focus on emulator specifically, how to bypass that detection. In this case we have a specific app that we are going to practice on. So basically a typical app, it's like a shop application, and this is the login screen, and in this case the detection starts early. Basically if it sees that emulator is detected or the device is rooted, it just finishes the activity. How exactly is detecting that app is running on rooted device or on emulator? Well, there is a specific class for that. It's security utils. In the case of root checks, we already know how it works, guys. Basically, there's a bunch of those paths right here, and if it sees those, it knows, okay, I'm running on rooted device, because it sees superuser.apk or su or other folders right here. So if it can access those, it means, okay, we are running on a rooted device. This is the array of those files, and it basically just checks those using this for method. Checks, okay, we are running on a rooted device. Otherwise, if it cannot see those, it just returns false, and it means that phone is not rooted. In case of emulator checks, well, there's a bit more stuff happening. It checks for device fingerprints. For example, if it sees that device identifies itself as emulator or Google SDK or unknown or generic or Android SDK built for x86 or Genymotion, then it understands, okay, I'm running on emulator. In this case, it's just gonna quit, right? But if app is just running those checks, it's quite easy to bypass. But in most of the cases, it's not enough. So it actually runs those checks. It checks for the access to those files once again. Most of the times when we talk about emulator, we mean QEMU, right? Basically, this is like an emulation layer. It checks for those paths right here. It's a bit more complicated check, but it's also quite easy to bypass using Frida or other tools. So let's actually see how to bypass it using Frida. So this is how the check is actually happening. I'm running on my rooted Pixel 8 device. I press start and let's see what actually happens. It starts the app, it says device is rooted and running on emulator, and then it just finishes the activity. App realizes that we are running on emulator and it just stops working. Okay guys, so we need to either write our own script to bypass the root checks and emulator checks, or just find the script on codeshare.frida.re, for example, or any other resource. There are multiple scripts available, but let's take a look at the one that we need. This one, for example, this is just for SSL pinning bypass. No, we don't need this one. This one is only for root detection, Frida anti-root, Frida multiple unpinning against for unpinning, and this one is actually what we need. As we can see, SSL pinning, root detection, and emulator detection. So multiple cases right here. Let's take a look here. Yes, it helps bypass those checks for those paths in the system. What about emulator checks? Yes, bypass emulator detection. As you can see, it's actually quite more robust. It allows to bypass a bunch of stuff right here. Yeah, anti-root detect. It also bypasses the libraries like lib.so, native checks, and much more. Well, that's actually really useful script right here. A bunch of stuff we can see. If we check for QEMU, we can see that it's actually checking those as well. QEMU pipe, QEMU-D, so it should actually help to bypass our checks. Let's try it out and see how it works in our scenario. Guys, do not forget to start the Frida server if you're running it this way. So basically you need to have Frida server running on your device. Without that, it's not gonna work. Frida client needs to communicate with Frida server to bypass this check. So let's go, let's see how it works. Alright, so it starts. As you can see, it actually bypassed all the checks, and now the app actually works. We can type our credentials and log in into the app. Basically, this is the simple app that I specifically wrote for those purposes, and I'm going to use it further in the future videos, so stay tuned. As you can see, bypass return value for binary superuser none, for binary none, and basically just a bunch of checks. SSL pinning checks in this case are not necessary, so in this case it's only about root and emulator checks, and in both cases it worked fine. It actually bypassed those. Thank you guys for watching, stay tuned for more, please subscribe, press the like button, and see you soon.